Welcome back. If you haven't attempted number 3 on your own, please do so. Just like before, we are going to read the problem. It says, upon reaching the top of the building, the elevator accelerates downward at 3 meters per second squared. So maybe they're moving upward but slowing down, so that would be a downward acceleration. They want us to find the force normal. Oh, they want us to build a force diagram for the man and then find force normal on the man by the floor. As always, we want to define the system in the picture. We did that in the previous one, and then write down the given information. This is the same man, so the mass is still 85 kilograms. His weight is still the same, negative 850 newtons that it was in the first problem. This time we see an acceleration that is 3 meters per second squared. And the fact that it says it's accelerating downward, that's going to make that a negative 3 meters per second squared. And again, they want us to find force normal on the man by the floor. So, force diagram, here's the center of mass. We're going to use the exact same size force of gravity as we did in the previous one. The force of gravity on the man by the earth equals negative 850 newtons. And then we need a force normal on the man by the floor. Now, if you're accelerating downward, you have to have a net force. What direction would the net force be if you're accelerating downward? You'd have to have a net force that's downward, which means this upward normal force has to be bigger, smaller, or the same size as gravity. If your net force is downward, that means gravity has to be bigger than the normal force. So we need to draw the normal force smaller than whatever we said the force of gravity was. Next up, we know the mass of the person and the rate of acceleration, so maybe we can use net force is mass times acceleration like we did in problem 2. We know the mass of the man is 85 kilograms. We know the acceleration is negative 3 meters per second squared. And 8 times 3 is 24, so 80 times 3 would be 240. 3 plus 15, so that's negative 255. A kilogram times meter per second squared is a newton. And our net force is negative 255 newtons. Now we can use the net force as the sum of the forces. Force normal on the man by the floor, plus the force of gravity on the man by the earth. Put our vectors in there. I'm missing some other vectors in here. Fill those out as we go. We know the weight of the man is negative 850 newtons. We have already calculated the net force is negative 255 newtons, and we're going to use that to find force normal. So to get force normal, we're going to have to get rid of the negative 850 newtons, so we're going to add 850 newtons to both sides. And that leaves us with a force normal on the man by the floor. These cancel out over here. And let's see, this would really be 850 minus 255. So I think that ends up being 595 newtons is the force normal on the man by the floor. So that's how to do problem number 3. If this is 2022, we ended at this point and we did not assign any additional problems in this packet at this time. I hope that helps.